In this section, we're going to talk about lines. Much of what we say about lines is going to be review, and so I'm going to be going through it relatively quickly. For example, in this video, we're going to talk about the equation of a line and what it looks like. Lines in a plane, straight lines that don't curve at all, are described by linear equations in two variables. And we have a variety of stock forms that we might encounter one of these equations in. The first one is the slope-intercept form, where x and y are our variables, and then m and b are known numbers. M indicates the slope, and b indicates the y-intercept. The slope is a description of the direction of the graph. It says every time we go 1 to the right along the graph, how far up or down do we go? The second form we often encounter lines in is standard form, where we have a number times x plus a number times y equals a third number. And then there are some restrictions on the coefficients, just so that if you write the equation of the same line in standard form, it will always look the same. We will often not care that much about these restrictions, but technically to be in standard form, each of your coefficients must be an integer, and they must have no factors in common to all three, and your first coefficient has to be positive. The third form of a line that I think that many of us tend to forget, but it's incredibly useful to know, is the point-slope form of a line. And notice I said the standard form and the slope-intercept form, but only a point-slope form. There's a point-slope form equation for every single point on the line. It's entirely possible to write down two different-looking equations in point-slope form that describe the same line. We'll never take an equation that we already have and rewrite it in point-slope form. The purpose of this form is to be able to easily write down the equation of a line. So the equation is y minus the given y is the slope times x minus the given x, where we're given an x and y, and we know the slope. And what this is, if I take this equation and divide both sides by this factor, I get y minus y naught over x minus x naught equals m. And this is just the slope formula. So the reason that we have that form of the equation is we take the slope formula, multiply both sides by the denominator, and there we go. So, just to refresh our memory of how to work with lines, I have a line graphed here. I'm going to give an equation in point-slope form, and then I'm going to rewrite that equation in the other two forms that I'm interested in. And the reason that I'm going to give my equation initially in point-slope form is that that's easiest. To give an equation in point-slope form, I just need to find two nice points on the line that I can read. Here we are. And then I'm going to somehow come up with the slope. And there are two ways I could do that. One, I could do arithmetic. So if I call this A and B, I can calculate my slope as, let's see, this is -1, 1, and this is 1, -2. So if I subtract my y's, subtract my x's, and then divide. I'll have -2 minus 1 over 1 minus -1. That'll be -3 over 2, or -3/2. I could also do that by counting on the graph. To go from A to B, I go 2 units to the right, that's +2, and 3 units down, that's -3. Up is positive, down is negative. Right is positive, left is negative. Okay, now that I have the slope, I can choose either point. I'm going to just choose this first one because I can. I'll have y minus the given y is 1 equals -3/2 times x minus the given x is -1. So that is the first answer, point slope. And I can just leave it like that. I can leave minus -1, I can just leave it be. If I was feeling ambitious, I would rewrite it as x plus 1, but I don't need to do that to have an equation in point slope form. Now to get slope-intercept, I take that equation that I have and solve it for y. So first I'm going to distribute that -3/2, and then I'm going to add 1 to both sides. And there's my slope-intercept form. To get standard form, well, I need to have all my variable terms on one side. So I'm going to add this 3/2 x to both sides. I'll have 3/2 x plus y equals -1/2. And then I need to get rid of the fractions. So I'm going to multiply both sides by my least common denominator, as I do when I want to get rid of fractions. And we'll get 3x plus 2y equals -1. And that gives us our standard form equation. Notice a is 3, b is 2, c is -1. They're all integers, and they have no factors in common, and the first one is positive. So we did 3 things in this exercise. We wrote down an equation from a graph. Then we arranged an equation in slope-intercept form by solving for y. Then we arranged an equation in standard form by getting all the variables on the same side of the equation.